Hey yo, how you doing, my friend? The Christmas is coming. Mhm. Okay, and today I'm gonna back with a new video on Mastercam Multiaxis, and we have a case study today. Okay, uh, you may remember in the last video I just talked about how we can do a 3D ramping using the flow light toolpath. Yeah, and you can see the slot is not a real 3D because it's just a flat a slot on a flat surface, but it's taper. Yeah, but today uh, we have a real 3D part. You can see we have some slot here, and yeah, they are real 3D. Yeah, the surface here is not flat, not taper, is a 3D surface, so you can see the slot is 3D also. Okay, and today I'm gonna use one multi-axis toolpath to do the ramp motion for roughing the slot. Okay, but before we begin, I want to talk a little bit about a term that we call the surface normal. Okay, so what is a normal, a surface normal? I will create a vector. Sorry, I will create a surface and I will show you. Okay, no, sorry. Okay, I'm gonna create a surface. So this is a simple flat surface. So what is a normal or a normal vector? Or we can call this a normal. A normal vector is the vector perpendicular to the surface at a given point. So a surface we have one normal vector at a given point. In Mastercam, there's one way you can create a normal vector for a surface at a given point. You go to the line here, and we have a line normal option. We click on this, and you can see this is my surface. And when I click on the surface, you can see the normal. Yes, the green vector, this is the normal vector as every point. And you can take a note on the direction of the vector. You can see it's point upward. Yeah, it's point upward or point far away from the surface. That's in the direction of the normal vector. So I click on this, and you can see this is our normal vector as this point for this surface. Yeah, and I will do the same thing with this solid. You can see take a look on the direction of the normal vector. You can see it's point outward far away from the surface. Here we try with another one, this one. Okay, you can see in a solid, the vector the direction of the normal vector is only point outward. That means point far away from the solid surface. Yes, we have only one direction at one given point. So if you have a point here, and the normal vector will the direction of the normal vector will go like this. It's point far away from the surface of the solid. So we cannot change the direction of this normal vector because this is a solid surface. Okay, so how about this surface? This is not a solid surface, so we can change the direction of the vector. I will create another one so you can easy to see. This is my second surface. Okay, I create a normal vector on this, and you can see this surface and this surface had the normal vector has the same direction, it point upward. So how you change the how you change the normal vector of one surface. Mastercam allow you to do that. You go to the surface tab here and you can find the change. So this with this option you can see the normal direction of one surface. You can click on the change. When you click on this, you can see here, yeah, you can see the difference for this surface and this surface. You can see in the in this side, you can see the color is different with this side. On this side the color is look like orange, and on this side I don't know what this color called, but you can see the difference. And there's one rule in Mastercam, that's the side with the orange color is the side of the direction, yeah, you can see. And the green color is the other direction, yeah. So you can see for this surface, if we change click on this, it will change the direction of the normal vector. So you can see this side now have the orange color and the green color change to here. You can only see this when you click on the change button, and you can see we have two surfaces with two different normal vector direction. So I will create a normal vector again. You can see the difference for this surface. Yeah, we can see we have the same result. The normal vector points upward. Okay, and for this one, you can see the normal vector points outward. Yeah, we already changed the normal of a surface. Yeah, so when you click on the change button here, you can see the direction of the normal vector. Okay, and you can change it if you want. So why I talk with you about the normal vector, because in multi-axis is quite important. um, the normal vector of a surface is will define the tool axis direction. Yeah, okay, let's see. I have an example, very simple. I got I will create a bum, 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 a project curve toolpath here. Okay, I select the tool and I select the curve. You can see I have I'm gonna select this and this curve, and then I'm select the tri surface. I click on this and I have two tri surfaces. Okay, and I have some input, some parameter. So I have the tool axis control here. It will say perpendicular to the surface, and okay, and now you can see do you remember the normal vector of this surface? Yes, it's point upward, and so you can see the tool is stay in the stay on this side, in the upper side of the surface. But when we go to this surface, you can see the tool change the direction. The tool exit will stay in the lower side of the surface. So, and when we can change. And if I change the normal vector of this surface also, you can see the difference. Okay, I have some problem with the Mastercam, and you can see after I change the normal vector of the surface, we can see the tool direction change. Now the tool stay upper of the surfaces. Yeah, I can try to change it again. Now we change this surface also. Chew. And now you can see after we change the normal vector, the tool axis also change. Yeah, that's yeah, if you're in a multi-axis toolpath, if you control the tool axis using the normal vector of the surface, so the normal vector is very important, and you can only see the direction of one surface. If you click on the change button here, you can see the orange color is the normal direction and the other is the reverse direction. Yeah, and or you can also use the line normal here. You can see if you click on a surface, it will show you the direction of the normal vector. It's very simple, right? Yes, that's it for the surface. And as I told you before, we cannot change the normal direction uh, of a solid face like this one. Okay. All right. Back to our project. I just talked with you about the surface normal, and now we're going to cut these slots. Okay, take a look on this. I have 4 slots here, and I will measure the distance between. Okay, so you can see the width of the slot is 10 millimeters. So my plane I gonna use a 6 millimeter flat end mill to cut this slot. Okay, and I will do a fully ram for this slot. Okay. And what toolpath I'm gonna use today? We go to the toolpath and multi-axis here, and we got the project curve. Yes, this is a very popular. We use it for the multi-axis chamfer in my other video. Okay, and we use it again today for multi-axis ramping. Okay, click on this. All right. First, I wanted to see how this works. For the project curve, you will ask to select some curve and ask to select some surface, and the curve will be project onto the surface from a direction you can select it. Yeah, and the tool will follow the project profile of the curve. Okay, we select the project curve toolpath and wait a minute. Okay, first we select the tool and we go to the cut pattern. Here you can see we have the pattern here, and we can select the curve by clicking on the projection here. Yeah, and then we will be asked to select the curve. For example, I want to machine this slot first. You can select by 3D or yeah, wireframe if you have already have the wireframe. For a slot like this, you can select the curve on the upper face here. Okay, like this, you can select this curve, or if you don't want, you can select this lower curve here. Yeah, anything you want, they work, but in my opinion, I recommend you to select the lower curve. Yeah, it's a little bit easy for you. Okay, we can select as many as you want. Okay, and after we select the curve for projection, we need to select the projection direction. In this case, we just use the surface normal to use at the projection direction. Okay, and the curve will be project to the surface using the surface normal direction. You also have an parameter here that's called a maximum projection distance. Yeah, if the curve here, if the curve you selected is not laid on the surface, so you need to define a maximum distance. If the distance between the curve to the surface is greater than this value, you will you will not get any projection. So if the curve is not laid, if the curve not laying on the surface, you should input a greater value. For example, maybe zero point 0.5 or 1 millimeter. Yes, it depends on the position from the curve to the surface. You can input a large value. Okay. Next, we have to select the dry surface. That is the surface the curve will be projected. Okay, click on the dry surface button and we can select. Okay, I try selecting this surface. Yeah, we can use this internal surface for projection. Okay. Ooh. Bing. Okay, I have already select the surface. Done. We have a parameter called the dry surface offset. If you input 0, the tool will stay in contact with the dry surface. If you input a positive value, the tool will stay away from the surface. And if you input a negative value, the tool will go further and cut into the surface. I will start with the 0 first. And the cutting side, we have a center, left, or right. It's like in a 2D contour. If you select the center, the tool will cut at the center. Okay, I will try the center first, and you can see what happened here. The first thing you can see, that's the tool cut from this direction. That's the tool cut from internal. But I want the tool cut from outside to inside, not from inside. Yeah, so you can see. First, you can see the tool stay cut from this side of the surface. That's what we don't want. Okay, and when we choose to select cut at the center, you can see the tool center will follow the projected curve. There's one thing we need to check. You can see the tool path is not smooth here. It retract here, and this not make a full cut. You need to go to the collision control and uncheck this. Test it again, and now you can see we have a smooth cut. You can see the tool axis stay perpendicular to the surface. That's mean the tool axis defined by the normal vector of this solid face. And as I told you before, uh, the normal vector of a solid face is always point outward, so that's why we have the tool pointing in this direction. This solid face and the normal vector points outward. That's why the tool stay on this side of the surface. And the tool cut at the center. We don't want it cut at the center. I want it to cut on the left side. Okay. And you also have the cutting side offset here. That's the material you lift on the side of the curve, like we do in a 2D milling. Okay. So you can see when I select cut at the side of the tool, you can see it's cut at the side of the tool, and when we select the left, it's cut outside. Now we need to change something. First, I don't want the tool cut from this direction because this is where our fixture staying, and we cannot cut from this direction. I want to cut from this direction, and I need to change the surface normal, right? As I told you before, we are unable to change a normal of a solid face because it's always point outward like this. So we need the solution is we need to create another surface based on this surface. Okay, we go to the surface here and we got a function called that the surface from solid. We can use this to create a surface from a existing solid face. We just select the face selection here and click on this and press enter. You can see we have created a surface from the solid face. Yeah, very simple. And we can check the normal surface of this face. You can see because it's created by the solid, this is the normal vector of this surface. It's the same with the solid normal vector. So you can left the surface like this, or you can um, fill this gap. Is no problem. You can use the remove boundary here. Click on this and click on the surface. Move around to the gap. Click and do a mouse click. Okay, so we fill the surface. You don't need to fill the surface. It's okay. Okay, now we have the surface, and now we can easily change the surface normal. Yeah, that's it. The tip. We don't change the normal of a solid face. We change the normal of a surface. Yeah, we just click on the chain, and you can see the green color. We want this face at the normal vector, so I click on this surface, and you can see the color change. That means the normal vector had changed the direction. Now I go back to the toolpath, and I'm gonna reselect the surface. I remove the old surface and select the new one. Click on the new surface here. Choo. Okay, let's see if we have any different. Ting 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 ting. You see that after we change the normal vector of the surface, we have the right cutting direction. Yeah, you can see this is a multi-axis cut, and you can see the tool stay perpendicular to the surface we have created. Okay, the first problem we have solved, that we change the tool direction. Okay. Oh, let's see. Take a look on this. You can see the bottom of the tool is not go through the surface, so we need to the tool to go through the surface. So we go to the parameter here and change one parameter. Okay. In the cutting side, in the right surface offset, I input a negative value, for example, -1. Okay. If you input a negative value, the tool will go further into the surface, like this. You can see that. I just input 1 millimeter, and you can see the tool go through the surface by a distance of 1 millimeter. Yeah, so now we can cut through the part. Okay, another problem we have solved, but we have another problem. Okay, I can back it. All right, take a look at this. You see the problem. When you input a -1 value for the surface offset, you can see the tool will also go far away. It will go through the curve here. You can see that it's not contact with the wall anymore, and now it's cut further to the wall here. You can see, and this distance is also 1 millimeter, so that's what we don't want. It destroy our slot, you can see, and the greater value I input, for example I input, the further the tool will go. So you can see now it's cut through the slot like this. Oh, that's the nightmare, right? So we need to solve that problem. In the cutting side offset here, you can see, yeah, we can change this. If you input here -1, you should input here +1 for compensating. Yeah, if you input -1 here, you should input +1 here, and the same for 2. It should be -2 here because we have to compensate the tool. Okay, compensate for the tool. All right, and let's check it again. We input -1 and the tool go through the surface here, and we check on the wall here. Dang, dang, dang. You can see now the tool is not cut further from the wall. It follow the wall now, right now. So it's very simple, right? Yes, just keep remember if you input -1 here, you should input +1 here. Yeah, very simple, right? And if you want to go deeper for the -2, and if you keep this one, you still have a graph. Oh, yeah, you can see it's still cut into the wall, so we need to input a correct value. That will be my sorry, +2 to compensate for the -2 here. Okay, dang, dang, dang. You can see. Ah, yeah, we go deeper, -2 mm, and the tool still follow the wall of the slot. Yeah. So one problem solved. Uh, -1. I just want to go through 1 mm. Don't go so far. This okay, but that's not but that's still not what we want. I want a ramping, a multi-axis ramping motion. Yeah. That's just a contour, not a ramping motion, because we have to rough the slot. So how to do the ramping? First, you need to measure the thickness of the material, the thickness or the depth of the slot. I can check it through a measure. This line you can see, yeah, it's around 5 mm thickness, 5 mm thick. So if you want to go a ram with a 1 mm depth of cut, so we need to go 5 circle, okay, 5 depth and 1 mm for one depth. Okay, to do that we go to the roughing here, and we have the depth cut option. Okay, we activate it. Sorry, we have here the number of rough pass and the spacing between each pass. Okay, like I mentioned before, I have a 5 mm thick, so I think yeah, and I have 1 mm go further from the surface, so I think we go with thick, and 1 mm for each pass. Okay, and then click OK to see what we have. Yeah, cool. Now you can see we have multiple depth of cut, 6 depth and 1 mm for one depth, like this. But that's still not what we want, because you can see in the end of the motion the tool plunged into the material, and that's not good. We want a ram, we don't want a multi-depth. Okay, you can see it's plunged into the material here, and that's what we don't want. We want a ram motion. Okay, so how we do the ram motion? Just click on the use ram here. Very simple, right? Shoo, and we got the ram motion. Very simple. And you can see this is the ram motion. And take a look on this. You can see we have a smooth ramping from top to the bottom of the slot. Yeah, this is the ram. You can see no transition. So it's quite simple, right? Yeah, you can also use the lead in and lead out for the toolpath, but I don't have so much time to talk about it. You can use the linking here, and you can define the lead in and lead out motion, also the transition between um, the layer, or between a slot to from this slot to another slot. You can all is you can find in the linking parameter here. Okay, so we have finished cutting one slot, and yeah, you can use another toolpath for finishing. It's no problem. If you want to leave stock for finishing operation, you can go back to the cut pattern here, and instead of cutting side offset the 1 millimeter, you can input around 0.1 for for finish operation. Yeah, this is up to you. Okay, we have cut one slot and we want do the same thing for 3 other slot. We can cut many slot that we want. Just go back to the toolpath and we select a new chain. Okay, we go to the edit curve here, click on the projection, and we select more chains, add chain. Okay, ping, oh, ping, oh, ping, oh. Okay, and we have 4 chains. We don't have to select more surface because yeah, this surface is cover all of our slot. If the surface is not cover all of your slot, you need to add more surfaces. So this is very simple. Okay, and ping. All right, ding 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 ding. Oh, you can see what happened. It's cut here and it jump to another slot. It cut one pass and it jump to another slot. Yeah, that's really stupid, right? And we jumping. We don't want it, so we back to the toolpath parameter again. We go back to the roughing, and we have something called a sort by. Just click on the slide here, and you will cut. It will reorder the cutting. Okay, you can see we finish one slot and we jump to another slot, and we jump to another, and we jump to the last. Yeah, this is cool, right? So I think it's done. It's quite simple. Just remember, we need to take care about the surface normal. Yeah, if you see that color, that means this is not the normal of the surface. If you see this color, yeah, it's the surface. It's the normal of the surface. You go in the right track. Okay, yeah, and we cannot change the normal vector of a solid face. So the there's one solution for this: creating a new surface based on the solid face by using the from solid option here, and you got a new surface. And with this surface, we can change the surface normal. Yeah, very simple. Okay, let's try seeing the cut on the verify environment. Okay, so this is my part, and see, yeah, the tool here, and it's go ramping. This is the ramp motion. Yeah, that's look cool, pretty cool. And if you have a 4-axis machine, is you can choose the 4-axis output. Yeah, it's very simple and cool. Nice. It's very nice. Okay, you may ask how I set up the stock. I have 2 level. One level is this solid. I use this solid for stock, and one solid for for working. It's simple. All right. Let's see what we have. Okay, I think that's enough for today. And if you have any questions, just ask, because I just studying, still learning. Multi-axis is quite pretty new for me, and we can learn together. Okay. Okay. I wish you a Merry Christmas, and okay, goodbye for now. Bye bye.